Scientific notation, also called standard form, allows us to write a number in a more concise form. We have to, this letter A that's out in front has to be between the numbers 1 and 10. So for example, it can be 1 point something all the way up to 9 point something, and it's always multiplied by a power of 10. And this power of 10, the exponent of which has to be an integer. K has to be an element of the integers. So how do we write a number in scientific notation? It involves moving the decimal point, whether left or right, depending on the expression. So if we want to write 23,600,000 in scientific notation, we currently have the decimal point here. We're simply going to move the decimal point to the left until we get a number that is between 1 and 10. So in this case, it'll be 2.36. So we've moved the decimal place 1, 2, 3, 4, 5, 6, 7 places to the left to get 2.36 times 10, and then the number of places that we've moved the decimal place. We moved it to the left, so 2.36 times 10 to the 7. If we want to write the following example in scientific notation, we have to move the decimal place to the right. So 1, 2, 3, 4, 5. Now we've got 2.36 times 10 to the negative 5. Because we've moved the decimal place to the right, we need to represent that as 10 to the negative 5. If we want to write the following that's already in scientific notation, if we want to write it as a standard decimal number, we're going to take our 2.57, and it's times 10 to the 4, so we're going to move that decimal place 1, 2, 3, 4 places to the right, and fill in any gaps with zeros. So we've got the number 25,700. Same thing here. If we want to write this example as a decimal number, so we're starting with 2.57, and it says times 10 to the negative 4. So we know that's going to make our number even smaller by multiplying by a negative exponent of 10. So we'll move our decimal place to the left. 4, 1, 2, 3, 4. The decimal point is now here, so we have 3 new zeros after a decimal point, so 0.000257. Okay, if we want to simplify the following using scientific notation, if we want to multiply these two scientific notation expressions, we can multiply the whole number, so we can multiply 3 times 8, we get 24. And then remember your rules with exponents. If they have the same base, we add our exponents when we're multiplying. So we have 10, we keep the base the same, and then we have to the power of 4 plus 3, or 24 times 10 to the power of 7. But this isn't this is not in scientific notation right now, because 24 is not between 1 and 10. So in order to do that, we can move this decimal place to the left, making this 2.4, and then we just have to add 1 more power of 10. And we get our answer. Here, remember with powers over multiplication, we're just simply going to distribute that power to both things in this equation. That only works with multiplication and division. Remember, it does not work with addition and subtraction. But what we'll get is 5 cubed times 10 to the power of negative 12. 5 cubed, so that's 25 times 5, 125, times 10 to the negative 12. And then again, we want to put that in scientific notation. So we're moving this decimal 2 to the left. which means we're actually adding to our power of 10. So we have 1.25 times 10 to the negative 12 plus 2, or in other words, 1.25 times 10 to the negative 10. Okay, with division, remember we can just divide our whole numbers. 8 divided by 2 we know is 4. And then with exponents, if we have the same base and we're dividing, we subtract. So we'll have 10 to the power of 4 minus a negative 3, or in other words, 4 times 10 to the power of 7. A minus gives us a plus. Here, if we can't simplify, if we can't immediately do 2 divided by 5, we can just leave that as a fraction. 2/5 times 10 to the negative 3 divided by 10 to the negative 8. Again, we have the same base, so we're going to subtract. We're going to have negative 3 minus a negative 8. 2/5, if we can turn that into tenths, that helps us. In other words, if we can multiply by 2 over 2, 2/5 is the same as 4 tenths, or 0.4, times 10 to the 8 minus 3 gives us 5. Okay, so we have 0.4 times 10 to the 5. We need this number in front to be between 1 and 10, though. So right now we have 0.4. We need to make that 4. So we have 4 times 10, and this will be to the 4th. We've moved the decimal 1 to the right, which means we need to subtract 1 from our power of 10. So 4 times 10 to the 4th. Okay, how many times larger is 5 times 10 to the 8th than 1 times 10 to the 5th? So in other words, what's 5 times 10 to the 8th divided by 1 times 10 to the 5th? We can divide our coefficients here. We have 5 over 1, which is 5. We have the same base, so we keep that base and we do a subtraction of our exponents. So 8 minus 5. And we get 5 times 10 to the 3. That's in scientific notation. If we wanted the number itself, the decimal, we'd have 5,000. When we take 5 and move that decimal place 1, 2, 3 to the right, 5,000. Okay, last one, which is the smaller of 3 times 10 to the negative 8 and 3 times 10 to the negative 10? Well, if we're talking about smaller, a more negative power of 10 is going to give us a smaller number. So we know 3 times 10 to the negative 10 is smaller. How many times smaller is it? We can divide once again. If we do the bigger one on top, it will still give us which one is smaller and how many times smaller. So we've got 3 divided by 3 we know is 1. We keep our base the same, and then we subtract our exponents. So negative 8 minus a negative 10, or in other words, 10 minus 8 is going to give us 1 times 10 squared, or 100 times smaller. So 3 times 10 to the negative 10 is 100 times smaller than 3 times 10 to the negative 8.